Good morning. I am not here today, so we're going to be talking about graphing functions. But before I do that, I want to show you what I was watching on the news today, and I'm sure a lot of you saw it. This is why we learn math. Now, not all of us are going to grow up to be rocket scientists, but this is some crazy math that you have to do in order to get this to launch. And what I found was so cool was that it actually came back. It's very cool. Yeah, and there it goes off into the clouds. I'm going to fast forward a little bit so you can see what happens. Part of the rocket booster comes off. Yeah, there's a parabola. Hello. Okay, so this thing starts to fall off. Okay, well, this thing fell off. Hold on, I got the wrong spot here. Okay, so this thing comes off. It's very cool. Yeah, it's going to go land back on the landing pad. It's very cool. So this thing's coming back down, and all right, so let's look to see what this one is doing. Here we go. I got another better one to show you on this one. Okay, so it's coming back. This one right here is coming back. This is up there in space. They're going on to go do whatever they're doing. This one's going to land. I've never seen such a thing. This is craziness. This is some major math going on. I can't even throw a rock and get it to land in the right spot. And they got this thing coming back from outer space. And they're going through the clouds. Oh, amazing. Look at this. It's going to land right on the landing pad. That's craziness. All right, and that's why we do math. Okay, so let's go on back to what we're doing today. So speaking of figuring out when something's going to land, that's why we do graph functions, okay? So let's look at how we're going to graph. I'm going to find the inverse of the function. There's some things you're going to do today on a worksheet that you've got. So you might want to practice these two with me and then do the worksheet. So let's say we want to find the inverse of that, okay? So remember, this is actually y equals 3x minus 5. We're going to switch our x and our y, and then we're going to solve for y. So we get, I'm going to come back over here, add 5 to both sides, and you get x plus 5 is equal to 3y, and then you divide everybody by 3, and you get x plus 5 over 3 is equal to y, but that's really your inverse. So our inverse of x is x plus 5 over 3. So let's go and graph both of them and see what they look like on a graph. So I'll graph the first one in red, so this one will be red. So 1, 2, 3, 4, 5, and my slope is 3, think I'm doing this right. Okay, so that's the first graph. My line's not very good. And then I'm going to graph the second one. Let's make that blue. And my y-intercept is going to be 5/3. So that should be right about there. And then x over 3. So it should look something like this. All right, if you're graphing both of these on your calculator, you could probably see it, what it's doing. I might be off by 1 point or so, but I'm doing this without a calculator. All right, so you've got two lines going on there. Now remember, they are symmetric to this line y equals x, so they look like a mirror image going on there. Okay, so on your worksheet, you'll have to do one of those. And then you'll also have to graph this, and then we're going to figure out different parts of the graph. So plug that into your calculator real quick. Got this on my calculator. Let me slide it over to get it out of the way. All right, so we can see what our graph, I don't know why it's showing all that stuff. All right, so we can go see what our graph, oh my, what did I do? All right, so we can kind of see what the graph is going to look like. Okay, so we've got, it looks like two parabolas going on here. So I'm just going to graph a real quick sketch of it. All right, so what I saw was like this kind of went like, I know I have a horizontal asymptote at -3, I'm assuming. Oh, no, I don't. Oh, yeah, because I got that x going on. So that -3 didn't have anything to do with it. So you don't have a horizontal asymptote at -3. You have a horizontal asymptote at 1. So I'm going to draw a little asymptote here at 1. Okay. And it looks like we have a vertical asymptote at 0. So I'm going to sketch the asymptotes first. Go back and look at what you got on your graph, okay? Or go to your table. You can go to your table and see what points you've got, and you can graph those. None of those seem to come out very well, but I do have a couple of them down at the bottom. So at -1 and -6, -2 and -4. I'm just going to sketch something real quick here, though, just to kind of show what it should look like. All right, it's going to go through here. Oh, wait a minute. Hold on. It looks like it's cutting through. It is going through at negative. Did my graph change? No, it did not. Okay, sorry. It does have an asymptote, a horizontal asymptote at -3. All right, I think I was looking at an older graph or something. So, it does have a horizontal asymptote at -3. And then it just kind of comes across like this. And my points might not be exact. Comes across like that. Okay, so you do have a specific domain. All right, it's going to be all reals except what number? Except wherever your vertical asymptote goes, and that's going to be at 0. All right, and your range, now it goes from the bottom, and it goes and it turns at -3, comes from the top, and it turns at -3. So the range is going to be all reals except -3. All right, now where is our point of discontinuity? Well, the only one we really have discontinuous, we only think going left to right, okay? So whatever's going to make that denominator be 0. So x cannot equal 0. And our asymptote is actually the line x equals 0. So if you notice, domain, discontinuity, and your vertical asymptote is x equals 0 are all the same number. Now you have another horizontal asymptote, y equals -3. All right, and let's go all the way back and talk about end behavior. So end behavior is what's going on the left And what's going on the right? Okay, so as x approaches negative infinity, y is approaching what number? Well, it never crosses this line right here. So it approaches negative 3. And as x approaches positive infinity on the right-hand side, y is also approaching negative 3. Now, we don't really talk too much about when x is approaching 0 on either side. We don't really get into it too much with that in Algebra 2. We'll do that in pre-calculus. All right, so that's what you're going to be doing kind of sort of on your worksheet today. So you're going to get something from your substitute, a graphing worksheet. You can work with your group. Make sure you put your name on it, and it is due today. All right, I will see you tomorrow.